to try and, no, I can't really double page it. We're going to keep on referring back to it. So here's our limit comparison test. Yesterday we went through this one. We took, this was our AFK, this was our given. Integral test was going to be really hard. It would have been like arctangent, and it would have been u is the bottom, du would be 2n plus 2, which doesn't quite match. Ethan, I know we could have done like +1 to make it +2 -1, and then we could have done stuff. But I was trying to show limit comparison tests that we could look at this term, and we could say, okay, in essence, I have an n, I have a linear over a quadratic. In essence, I end up with the same degree as just 2 over n. Now, is this the same? No, it's not the same, but I'm comparing it to simplifying all these, like addition, all the like binomial, trinomial. I'm just thinking, okay, I have 2, it's like I'm kind of comparing these two. I have 2 over n, that's in essence what's left over when I multiply everything by like 1 over n. I could do 1 over n, 1 over n, 1 over n, it's like I get 2 over n. What's 2 over n? Why is that helpful to compare to? Because it's easy, it's a p series, and p is equal to 1, so the series diverges. So I'm comparing this one to one that's fairly similar, just not as complicated. Fairly similar, and it diverges, and I'm saying, okay, well, what can I do? Could I say this one is always greater than? Always less than? Didn't want to do direct comparison test. But limit comparison test says, I don't care whether greater than or less than, let's just take a limit. So take a limit of what you're given over the one you're comparing it to. We went ahead and just simplified, got it. The limit is 1. What does that mean in our test? Well, if the limit of these two is greater than 0, whatever one does, the other does. So then I was able to say pretty quickly, okay, cool. Since the limit of this with that equals 1, since he diverges too. Done. Didn't have to do an integral. And geometric, p-series, nth term, none of those would have worked for this one. But let's try another one. Guys, what do you think we're going to compare number 2 with?
1 over 2 times.
Sounds like a good idea to me, huh? 1 over 2 to the n. Here. On the page, this is going to look messy, so I'm just separating the top problem from the bottom problem. What do we know about 1 over 2 to the n?
It converges.
It converges because of geometric, and r is equal to 1/2, right? How do we know that for sure? Oh, 1/2, 1/4, 1/8, 1/16. Oh, okay, geometric. Or you can think of it as, if you want, it's 1/2 to the n. Same thing. So we can say converges by geometric series since r equals. Okay. Well, why don't we just do direct comparison? Direct comparison. Hold on. How does 1 over 2 to the n compare to 1 over 2 to the n minus 1? Which one? Smaller? Oh, I heard smaller and bigger. Ah, which one is it? Smaller or bigger?
Bigger.
The bigger is
Greater than or less than?
Oh, we're talking about that one.
is
It's less than.
is less. No,
I thought we were talking about the one that we came up
it's
with.
bigger.
It's bigger than.
Which one? Oh.
Wait. Whose denominator is smaller?
Oh.
His denominator is smaller. When you have a smaller denominator, your number gets bigger. Now, if you don't trust me, hold on. What could you do? Could you plug in? So plug in 1. So 1 over 2 to the 1 minus 1. That'd be 1 plus. Plug in 2. 1 over 2 squared, 4. 4 minus 1 is plus. I mean, you should be good there. Plug in over here. 1/2, 1/4. Ooh, who's bigger? Does that make sense? So you could test that way. Okay, wait. Does direct comparison work? Does direct comparison work? What's this one? This one is the bigger one, so hold on, wait a minute. Direct comparison says, I have, Youngji, this is like your hand, right? This one's like your hand?
And, yeah.
Okay, I have this one. This one is smaller or bigger? Smaller, so hold out your hand. This one's smaller and it's converging. Oh, I know nothing, right? Does that make sense? So if I have a, look, you have to think about what you're comparing it to. I have a smaller converging, I don't know anything. Smaller converging, SC, I know nothing. South Carolina, that's weird. BC, bigger converging, bigger squishes in, that's good. Or SD, smaller diverging, that's good. But SC, I got nothing. So therefore, we can't use direct comparison. But does that mean I can't compare at all? Nope. That just means I'm going to do the other comparison. Limit comparison, because he's nicer. He doesn't make it bigger, smaller, anything yucky like that. What do I do with limit comparison then? I take the limit of what I'm given over what I'm comparing to. So what am I given? Okay, I'm given this term, right? What am I comparing it to? How do I simplify? Yeah, there's a few different ways of thinking about it. Ethan, go and explain why you said 1. They're tied, yeah. So you could think of it as simply as they're tied, so it's going to be 1. Or you could, I don't know, if you take L'Hopital's, you're going to take derivatives over and over and over. It doesn't make any difference. I think the best way to think is just they're tied, right? Or I could divide everything by 1 over 2 to the n, 1 over 2 to the n, 1 over 2 to the n goes to 0. Limit is 1. Ooh, 1 is greater than 0. We like it when it's a positive number because what does limit comparison test say? As long as limit is a positive, whatever one does, the other does. So, what's this series doing, guys? Got it. Since their limit was 1. So, picking might be picking something close, but it might also, with this one, it might just be thinking about the limits and saying, I really like it when it's positive. Does that mean I can't tell anything when it's 0? No, you can tell something when it's 0 or when it's infinity. Just have to be careful. So by the limit comparison test, we already showed the limit is 1, which is greater than 0. Therefore, he converges. Can we do another one? Let's do another one. Because if you guys remember, I think I said something about the AP guys on this, right? The AP guys like to, what did I say in the notes? You guys might not have been able to write it down yet. Logs. They like to give series with logs that need the comparison test. Well, let's look at our first one. Our first one with logs. Direct comparison test. Find something always bigger than or always, ew. Do you want to think about greater than or, no, me either. So we're not going to do direct comparison test because direct comparison test we have to know always bigger than or always less than, right? So let's do limit comparison test. But what do you think we're going to compare it to? Let's talk for a second. Wait a minute. Pause. Why don't we just do geometric series? That's not geometric series. How about integral test?
No.
No. P series? Nth term test. What's the limit as n goes to infinity?
That's going to be
Huh.
infinity over infinity.
It'd be infinity over infinity, so then I'd have to do L'Hopital's, right?
Yeah.
So I'd have to do product rule. Okay, it's too much. Whatever, right? Yeah, let's not do that. So compare to. What do we want to compare it to? Which one? ln n over n?
Just like
Just ln? Yeah. Well, we have one absent, and there's 5.
She's gone.
She's gone. Compared to. All right, we have a few different things. We have ln n, and we have ln n over n. Anybody else want to venture a guess? Mine's different than both of those, but we'll try one first and see if you guys like it. Let's choose first. We'll do one at a time. You guys don't have to write it down if you don't want to. You can just look. All right, Ethan, let's do yours first. What'd you say? ln n over n? Okay. We want to only compare to something that we can easily say converging or diverging. So, converging or diverging? Why? Take the integral? That sounds too hard already. Okay, take the integral, and then what? So then u is equal to, we haven't even gotten to, let's not do that one. I don't like that one. Does that make sense? We want to do one that's easy to compare to. Youngji, what did you say? ln n? How about that one? It diverges. Why? This one's fast. Because it keeps getting bigger, and what test tells me if it keeps getting bigger, it's going to diverge? Nth term test, right? By nth term test, since, what's the limit as n goes to infinity of ln? Yeah, which is not 0, right? So any limit that's not 0 means diverging. If it equals 0, we know nothing, but if it's not 0, we know diverging. Okay, so then what does limit comparison test have me do then with that one? What goes on top? The original, good. So the limit as n goes to infinity of 1 plus n ln of n over n squared plus 2 all over, 5, thank you, Youngji. Okay, I need to do the limit. So how do I do this, guys? Can I do that? And I can say, does my trick work okay? I always think about fraction and then I just flip it. Bless you. Now what? Do I have to do L'Hopital's right now? Is there anything else I could do first?
Cancel.
How? I agree. How? Top and bottom?
Isn't the bottom greater than the top?
Yeah, the bottom is greater.
How do you know?
Because of
There's
this.
this n squared here.
The degree of the top is n ln n, and the degree of the bottom is n squared. Well, right? Okay, so then what's my limit?
0.
Okay, so we could have done L'Hopital's, or we could say bottom wins, so 0. Wait, what does our test say about 0? Oh, go back.
Both converge.
Converges.
If the bottom converges, then the top converges.
So it doesn't work?
Wait, so it converges?
Convergence.
Oh, if
Oh,
the bottom converges. So did we figure out anything? No. But did we compare? Yes. Did we try? Yes. Did it work? No. That's why I said you don't have to write it down yet. Okay, so hold on. Do we want to compare to ln when we have ln? No, because diverging. How about ln n over n?
It's okay because now it's equal to 1. And then it's not that hard.
ln n over n. How about 1 over n?
1 over n
Diverges by? Uh-huh.
n squared. Yeah, it worked.
A little bit easier? I was trying to make this easier. Diverges by p series since p equals 1. Limit as n goes to infinity of 1 plus n ln of n over n squared plus 5 all over 1 over n. Why did I do 1 over n? Well, if I was thinking of limit, what do I want the limit to be to make it so easy on me? What one does, the other does? What's the best one? If I can get it being 1 or 2 or 3 or 4, I want the degrees to be tied. Look at the problem. Were the degrees tied?
I think this one is C.
Oh, yeah, it's gonna time.
Infinity.
But then if I do, well, yeah, let's think. Hold on.
Yeah, it's gonna time.
The 0, getting it equal to 0, getting the bottom to win didn't work. Getting the top to win. Wait, why is the top winning all of a sudden?
Because you can cancel n squared.
Because now I have n squared times ln n over n squared. Well, who wins? N squared times ln n or over n squared?
The top one.
The top wins. And if we didn't know for sure, some of you guys are like, you gotta be kidding me. How are you able to know whether or not it's winning or not? Well, couldn't we do the following? Couldn't we see this as the limit as, just rewrite it a little bit, n goes to infinity of, and distribute in, and I would get n plus n squared ln n all over n squared plus 5. And then if I was to do like the old-fashioned way that we did before, I could multiply top and bottom by 1 over n squared. We could do L'Hopital's, but if you guys notice, that's product rule, that's gross. You would end up with the limit as n goes to infinity. I'd have n over n squared, which would be 1 over n, plus ln over n, because the n squareds would cancel, all over 1 plus 5 over n squared. I'm just distributing in. Well, as n goes to infinity, that goes to 0, that goes to 0, and what does the limit go to? Limit goes to infinity, but wait, limit comparison test. What happens if I go to infinity? If limit is infinity and the bottom diverges, the top diverges. Wait a minute, didn't I just have bottom diverging?
Yeah.
So I didn't necessarily get the whole L equal to 1, the one I really, really like, but I did get one that I was able to say, oh wait, I have And Youngji, here's what we need to think about. You picked one that diverged and we got a limit of 0. We wanted to figure out diverge one where limit equals infinity. Then I can prove it. So I chose one where it wasn't as strong. Where the top did win, where this one did win, but the bottom was diverging too. The limit is infinity, so therefore I can say by the limit comparison test, my series diverges also. I can say mine does too. I know, it's weird. It's weird. Let's see if we can do 2 more. I want you guys to just take a second, and I want you to, on number 4, try to pick one. And then take a limit.
What's the step one?
3 halves. Yeah, it's 3 halves. If you think about what I did before, it had an ln, but I didn't worry about the ln. Maybe that'll give you a strategy. It had an ln, but I didn't worry about it. I compared to something without an ln, because ln's make everything complicated.
Is that 3 over 2?
Mm-hmm. I think it's 3 over 2. Pick one, try one. Just pick one, try one. My hint was don't use anything with ln. Right now, if I take the limit, which one's stronger? Bottom stronger, limit is 0. I know nothing. Yeah.
You multiply bases to different exponents, you add them.
You add the exponents. I know it stinks, guys, but it's trial and error. Can someone give me one they tried? Just one they tried?
1 over n.
1 over n. What else did we try? Let me hear. 1 over doesn't work. And 1 over n, did it work?
I mean, like, if you use
Yeah, if you try the
direct
limit.
comparison,
Uh-huh.
you can, like, 1 over n is smaller, so it's gonna diverge, and it's gonna
Go
push
to
out.
infinity?
It's gonna push out like that.
Oh, direct comparison. You're doing direct comparison?
I don't know if it's
I'm
right.
bothering you again.
No, you're good. No, it's on this time. I just felt that last time.
No, it's alright.
So here, let's see what Kaiki was doing. So you say compare to what? Compare to
1 over n.
okay. And then guys, he already knew it because he already did it. What do we know about 1 over n? Diverges y. P series P is equal to 1. So then we know diverges. But what do we do after the step? Okay, direct comparison, Kaiki, walk me through that again. So direct comparison, what do I know about ln of n over n to the 3 halves and 1 over n?
1 over n is smaller
1 over n is smaller.
because
How come? How do you know for sure?
No, I don't know for sure. I just.
See, there's the problem. Okay, now hold on. We said a second ago we could plug in stuff, right? So wait, this one could be ln of 1 over 1 to the 3 halves, and then ln of 2 over 2 to the 3 halves, and then ln of 3 over 3 to the 3 halves.
I tried to play it off.
And what was this one? 1 over 1, 1 over 2, 1 over 3, 1 over... I don't know about that. Right? Let's not make ourselves stress about that. So let's try limit comparison test says you don't have to know greater than or less than. So what if we did start taking a limit? Hold on. I want to draw my line because now this is getting all confusing. Okay, limit comparison test. We're just trying something, 1 over n. So what happens? Yeah, how come? Because I think it's kind of like the one that you tried, right, Ongji? What happens when you do it? You end up with... Well, it's going to be a limit, though. What's your limit? Let's just practice taking limits, because we can see they're important now, right? Oh, ln of n, sorry. Okay, so then I do infinity over infinity, blah, l'hôpitals, right? So 1 over n over 1 over... Does it make sense, l'hôpitals? So I have 1 over n over 1 over 2 root n. Oh, crud. Who's stronger? The bottom's stronger. So, so my limit is 0. Ooh. Okay. 0. We can only show with 0 converging. Wait, how do I remember that? Wait, hold on. Is there a way to remember 0 converging, infinity diverging?
Yes.
Does this make sense? Can we memorize this? 0 converging, infinity diverging. Doesn't that kind of make sense in the sense of if it's infinity, then if one diverges, other diverges. Infinity, one converges, I don't know. 0, one diverges, I don't know. But if one converges, converges. Anyway, just things to be memorizing. So problem, 0, I can only show converging. Did it work? Okay, so let's go back. I'm going to keep all this because we still want to do a limit, right? It didn't work. I know, that's the problem of trial and error, is figuring these things out.
I don't like this test.
How about 1 over, I'm still not doing an ln. N squared. Well, 1 over, we can think through this without writing stuff. You guys ready to think through so we don't have to write?
Yes.
1 over n squared converges. Why? P series, P is equal to 2, right? So 1 over n squared converges. If I take a limit, 1 over n squared is going to be like n squared over 1 when I take a limit, right?
Yeah.
But who's going to win? Oh, it's infinity. The top wins. Does infinity and converging work? No.
Can you do 1 over root n?
1 over root n. Let's try that. 1 over root n diverges. Diverges by P series because 1/2 is less than 1, right?
It's gonna diverge.
And if I did n to the 1/2, that would be ln of n over n. Who wins? 1 over n. 0, but diverging in 0. Wait, we're having this whole diverging in 0 and then infinity in 0. Is there something that's less than 2 but greater than 1? Because we tried 1 over n, it didn't work. We tried 2, 1 over n squared, that didn't work.
1
3
over
over 2.
n square root of n.
1.5? Less than 2 and greater than 1? Let's try that. So hold on, wait a minute. P series. I know, but we're going to look at it. Hold on. Hold on. Converges by a P series, right?
Yeah.
So then times. Wait a minute, that's infinity. Hold on. Is there something even? That's still too big. What's something smaller but yet bigger than 1? 5 over 4. What?
Over 4?
Isn't that still bigger than 1? So it still technically passes P series, but it doesn't cancel out the denominator. I didn't want to cancel out the denominator, Youngie, because of what you saw. It was infinity and it didn't work. But if I make it something that converges but doesn't cancel out, so now I have ln of n over n to the 3 halves all over 1 over n to the 5/4. Wait, 5/4 minus 3 halves. 5/4 minus 6/4. Ooh, n to the 1/4. Who's stronger? Well, L'Hopital's if you need to, right? Limit as n goes to infinity of 1 over n. Bring down the 1/4, negative 3/4. And then, just for those of you guys that are like, I don't see it.
I0.
Now I have 4n to the 3/4 all over 0. Not infinity. Converging 0. Got it. N to the 1/2, but n to the 1/2 diverges. Because remember, P series, anything between 0 and 1, I couldn't use anything between 0 and 1. And n to the 3 halves canceled out, so it looked like limit was infinity, so I couldn't tell. Therefore, series. Whew. All right, I know. Our brains are hurting, and we're like, blah, we're done. With the logs, am I having to compare to logs? No. I wanted you to see that. With the logs, we're not having to compare to logs, but we are going to try and compare two powers of n, and we might have to experiment a bit to figure out what powers of n. The sad thing is direct comparison. If it's easy, greater than, less than, I can just keep it super similar, but limit, it can be different. I just have to think about the limits being 0 or infinity, or I love it when it's a number, but it doesn't happen very often. For number 5, I know we're out of time. Let me just write down what I would compare it to, just so that you can see this is our last example. I would have compared it to what do you think, Ethan?
L became 1. So it's 2 to the n over 4n.
Actually, I would have done but that's not the only one that necessarily works. So that's what I would have compared it to. All right, kiddos. You got to get this homework done tonight for tomorrow, because we need to talk about questions tomorrow.